Hi guys, so we're going to continue with our derivatives of trigonometric functions. So we have gone over product quotients, all of those rules for derivatives. We're just going to be applying them now with functions that include trig functions in them. So if you look at the example given, I have two functions of x being divided by each other, meaning 1 minus sine of x over cosine of x. So I'm going to be using the quotient rule. So before I use the quotient rule, remember there is a rule of constant times a function. So if you look at 3 over 2, this is technically a constant being multiplied to this entire function. So what I'm going to do is, and you don't have to, it's just, to keep things kind of a bit more simpler when you're deriving everything. I'm going to put the 3 over 2 outside, and I am only going to find the derivative using the quotient rule for 1 minus sine of x over cosine of x. And then when I'm done, I'll bring down the 3 over 2 to the final answer. Just so I don't forget, I'm going to underline it in yellow. So since I will be applying the quotient rule for this, the numerator would be f, which is 1 minus sine of x. I'm going to put that further down. So f equals 1 minus sine of x. And then f prime, the derivative of any constant is 0, and negative sine of x. Well, I'm going to bring the negative down because technically this would be 0 minus, and the derivative of sine of x would be cosine of x. And then same thing here. G is the denominator. The function of x would be cosine of x. And if I take g prime, or the derivative of that, that would be negative sine of x. And the common derivatives are up here in case you need a reminder. For the quotient rule, I'm going to take dy over dx equals, and I'm just going to kind of give myself a reminder. 3 over 2 should be on the outside of whatever I'm taking the derivative of, and the formula for the quotient rule would be g times f prime minus f g prime all over g squared. So I may have put f prime g on the other formula. Remember, you're multiplying, so this order doesn't matter. Just make sure, note which one is supposed to be the derivative and which one is supposed to be the original function. So given this, I'm going to just replace everything with what I have. So I'm going to keep bringing down the 3 over 2. All right, so we have g times f prime, which would give me negative cosine x times cosine of x. So I'm going to kind of skip a step here where I write out what I'm going to multiply, and I'm just going to multiply it. So g times f prime, cosine times negative cosine is negative cosine squared. And then minus negative sine times 1 minus sine. So f times g prime. So for that, I am going to bring everything down just so you can kind of see the algebra of it. All over g squared. So g is cosine, and we're going to square it. I just copied what I wrote down onto just a different page, so I have a little bit more room. I don't know why this one didn't appear, but just a reminder, g is cosine of x. Okay, so we're going to work on the numerator. Remember the 3 over 2, we can keep bringing it down. You can just kind of bring it down at the end if you want to. For me, I'm just going to bring it down step by step. So I have negative cosine squared x. And I'm going to distribute this. First of all, I have a minus and a negative. So I'm going to note that this is just positive altogether. Probably not the best plus sign, but there it is. And then I'm going to distribute that positive sign to what's in the parentheses. And that would give me plus sine of x minus sine squared of x. Excuse me, all over cosine squared. And then from here, remember your Pythagorean identity. So I'm going to take a sidebar and just kind of note down the Pythagorean identity I am referring to. Cosine squared plus sine squared equals 1. And I do have a reference sheet of Pythagorean identities in case you want to just save that. So what am I referring to here? Well, I have negative cosine squared minus sine squared. So there's a couple of options here. You can change cosine squared in terms of sine squared. You can change sine squared in terms of cosine squared by just, subtracting the cosine square to the other side. Or you can factor a negative out and it'll give you cosine squared plus sine squared. So there's a couple of algebraic approaches that you can take with this. So for me, I'm going to, and keep in mind you're adding and subtracting here. So the order, 2 plus 1 plus 3, you can change the order around. I'm going to put negative, and outside of it, cosine squared plus sine squared. So meaning, I put negative cosine squared and negative sine squared. I'm just putting them together. But when I put them together, I'm going to factor the fact that they have negative outside of the parentheses. So that would give me negative, and in parentheses, cosine squared plus sine squared. You can always check the algebra by distributing, and it should bring you right back up here. Now, everything else I'm just going to bring down. That plus sine of x I'm going to bring down. That cosine squared I'm going to bring down. And now I'm going to start changing things. So, bringing down the negative, I know that cosine squared plus sine squared, because I manipulated it to be together, equals 1. So I have negative 1 plus sine of x over cosine squared. Okay. Copied and pasted what I had in my last line to this new board. I know it's getting a little tedious, but the good news is that you are done. You found the derivative. The only thing is that using your trig identities, which is again posted on the left here, you can simplify this even further. Sometimes it's the algebra that takes the most amount of work. So what I'm going to do is I'm going to drop down the 3 over 2 again. And here, there's a couple of options. You can change everything in terms of sine squared. You can factor to divide out. I'm just going to take an algebra approach and split the numerator. So remember when you were verifying trig identities or simplifying them, there was multiple approaches to get to the same answer. So same deal here. So I'm going to just start by splitting up the numerator. What I have here is negative 1 over cosine squared. And if I know 1 over cosine is equal to secant, then I know that 1 over cosine squared is equal to secant squared. That negative, I'm just going to bring it down. Plus, now sine over cosine squared doesn't equal to anything. However, sine over cosine does under the reciprocal identity. So what do I do with that extra cosine? Because it is cosine squared. Well, I can multiply it by a denominator of cosine as well. And in the numerator, it'll be 1. And remember, you can always check your algebra. If I multiply straight across, it will still bring me back up to sine of x over cosine squared, which is what I have here. But the only change is that now I can simplify both of these using trig identities. So under the quotient identity, sine over cosine is tangent. And 1 over cosine, we saw already, is secant. And I'm going to bring down what I haven't used or have already simplified, and that's negative secant squared and 3 over 2. So that's pretty much it. We could try to check if you could simplify a little further, but I'm just going to stop here because you can't. And there is one other thing you could do, and it's not a big deal. So you could write 3 over 2, since a lot of the multiple choice answers don't like Either one of these are going to be the answer. Don't like starting off with a negative. Remember the adding, 2 plus 1, 1 plus 2, it's all the same. So they would probably put the positive term, which is that tangent x times secant x first, and then write down the minus secant squared after. Okay, but that's it. I hope this helps, guys.